not complicated, but weird. And also one more, and that's it. And we go over the word problem. Es logaritmo, bueno, 1/3, 1/3, 1/3, logaritmo base 2 of x plus 6 is equal logaritmo base 8 of 3x. This is the first time okay, we are doing one problem. Maybe the install sky may be help. Isabela Crespo. So in this problem, it's the first time you face this situation. Okay, you have different base. So the property number 5, number 6, number 7, you cannot apply. Are the guy in class already? Yes. Abraham Delgado, yes. Yes. You are complicated, guys. And then that property we study is impossible to apply in this moment because this property assumes that the base is the same. In this case, the base is different. It's 2 and 8. Therefore, the only possibility we have is express both sides of the logarithmic equation using the same base. A similar idea for the exponential, no? Same base. However, the property number 8, do you remember, is the chain of base formula, que es logaritmo of the one base of the one number or expression is equal logaritmo of the another base que I call b of the same number or expression divided by logaritmo base b of a. This is the formula, and we apply the formula. So suppose you make a decision what way you prefer to do. You have two bases, 2 and 8. I propose you change 8 to 2. So you bring down this logarithm here, stay the same, but this I change using the chain of base formula. Entonces, in the chain of base formula, we have two bases. The original base, okay, in our example is 8, right? And the new base, que es b, que I assume to make easy, to make same base as 2, no? Actually is logarithm of base 2 of 3x, que is the expression inside this in our specific example. No? In the formula, I put x in general, but this is 3x divided by logarithm base 2 of 8, que is the original base. Okay, do you understand this idea or no? Confusing? Confusing or clear? Answer me.
Can you explain again how you got the logarithmic 2 and 3x, like that part?
This is our original expression I have. Using that formula, my goal is change from the base 8 to the base 2 because I would like to have the same base, 2 and 2. Entonces, logarithm base, in my mind, in my imagination, b is 2 because in my problem I need 2 here. 2. Of the same expression que es 3x divided by logarithm of b es 2, b, entonces es 2 of a, que a is the all base, que es 8. Got it?
Yes, thank you.
Okay, now, at that moment, I need to compute logarithm base 2 of 8, no? Because this guy participated in this problem, no? So remember, we have two possibilities, using calculator or by hand. What way you prefer, by hand or calculator?
By hand?
By hand. By hand, you assume. Okay, this is after I reinstall Sky, definitely is working. Okay, now suppose que I don't know. That vale. Y I transform it to exponential. The base is 2. The exponent is exactly the thing I don't know. Equal 8. Everyone follow me? The conversion logarithmic statement to exponential? In this case, 2 to the cubic power is 8. Therefore, it's obvious. Okay, x is 3. Okay, logarithm base 2 of a is 3 because 3 is the exponent. It's necessary to raise 2 in order to get 8, right? Okay, so you replace 1 over 3 logarithm base 2 of x plus 6 is equal logarithm base 2 of 3x divided by 3. Wow, this is cancelled. This 3 is cancelled with this. Therefore, stay alive. Logarithm base 2 of x plus 6 is equal logarithm base 2 of 3x. In that moment, crucial moment, important moment, if we have two logarithms equal each other and the base is the same, it's obvious that the argument inside the logarithm is the same because it's one-to-one function. And you have super easy linear equation. 6 is equal 3x minus x. 6 is equal to x divided by 2. X equal 3. Yeah, as always happen, mandatory you need to check in this solution into the original equation to verify it's true, to verify it's okay. Let's do it. It's 1/3 and the original. This is the original. One-third logarithm base 2 of 3 plus 6 should be equal, I clean that up, logarithm base 8 of 3 times 3. Let's say 1/3 logarithm base 2 of 9 should be equal logarithm base 8 of 9 again. So one more time, why no? To compare two logarithms, we need the same base. So I do exactly the same. I convert this logarithm from base 8 to base 2. So logarithm base 2 of 9 divided by logarithm base 2 of 8. Okay, I know very well in this part get 3. Okay? So not necessary to write like that, you replace by 3. And divided by 3, and multiplied by 1/3 is the same. Then this statement is true, super true. Not necessary simplification anymore, they're identical. Now, x equal 3 is the solution for this equation. Any question? Clear?
Yes.
Yes. Okay. May I erase the board? Yes or no?
Yes.
Let's do one more logarithmic equation, and immediately we start doing the word problem applications. Suppose this log of 3 plus x minus log of x minus 3 is equal log of 3. Okay, something is weird in this equation. Professor, there are no specification of the base here. So the specification of the base is missing. Why is missing? What do you think about this? When do no specification the base, default you suppose what? What do you suppose? Answer me. No idea. This is important. You need to know.
We could say it's 1 maybe.
No, staying.
10.
Staying because you need to suppose que es common logarithm. O sea, the convention, international convention, in any country of the world. When no specification the base is because the base is 10. Because it's common logarithm. Okay, remember we have two standards, the common, base 10, and the base 1 is impossible because the base of the exponential, no 0, no 1. Okay? Okay, but this is not important. Now, the important is, as always happen in any logarithmic equation, you condense the logarithm. So you apply the property number 6 to condense this and this in only one. Of course, subtraction to says division. Okay, now ready. One more time. If we have two logarithms and the base is the same, it's because the argument is the same. So you delete mentally the logarithm word and you focus in this equation. And this equation is super easy, it's linear equation, but you apply cross multiply, you know? You multiply 3 plus x times 1, it's just 3 plus x. And you multiply 3 times x minus 3. Okay. Now distributed is 3x minus 9. Okay, so now I propose you, for example, these 3 stay here, plus 9, I move to the left, and 3x stay here, minus 2, minus x, sorry, minus x. This is 12, this is 2x, divided by 2, x is 6. And the solution I need to check it, just in case in the original equation. Logarithm base of this is the checking part, guys. Important the checking. I need to see. I don't see the checking part, no credit in this question. 3 plus 6 minus logarithm of 6 minus 3 should be equal logarithm of 3. This is 9. This is 3. Should be logarithm of 3. For example, you apply one more time the property 6. And the property 6 convert these two logarithms in only one. If the division is 9 divided by 3, it obviously is equal to logarithm of 3. Therefore, logarithm of 3 is equal to logarithm of 3. It's true statement, therefore this solution works. Very well. Any question? No? Everything is clear? I promise in the review package we come back again to this equation, no? Exponential, logarithmic, easy, complicated. So let's move on now to the word problem. No? So you finish to copy that. You finish to copy that?
Yes.
Yes. Okay, those are word problems. I want to solve any word problem because it's important. I have PowerPoint. Okay, application logarithmic PowerPoint. Okay, the first application that we are studying is the finance, so investment. Okay, how the money that you deposit in one bank account increasing according to the compound interest formula. We have different kind of formula for the compound interest. Let me summarize the formula here in one corner here. Okay, capital A represent future value, and capital P represent present value. So you deposit the money in one bank account now. This is present value, P. And in 5 years, according to this problem, your money increasing, no? According to that formula. Look, 1 plus R over N raised to the NT. Who is R? R is interest rate. R is interest rate. Interest rate. Normally is expressed like a annual percent rate. In our example, is 3%. M is compounding. Compounding means the amount of payment period in 1 year. For example, so you have annually means que N is 1. Because in 1 year we have one payment, no payment, reward. Okay, so the bank reward you with the one specific amount of money. No? Si es semi-annually, is N equal to, and so on. Quarterly is 4. Monthly is 12. Weekly 52, because we have 52 weeks in 1 year. So it's the amount of the payment period in 1 year, 52. And daily is 365. Okay, this is the formula. So the formula is, we have different formulas. Look, this is a formula for the future value. We have the same formula, but in the problem that you want to find the present value, suppose que, present value. Present value is equal to future value divided by 1 plus R over N and NT. This is future value. This is present. The most common formula is the future value. However, suppose you want to planning something. Suppose you want to planning to have in the future one amount of money because you want to buy something. Entonces the problem say, what is the present value I need to deposit in my investment account to get in the future some money. So now you compute the present value. It's a one possibility. I don't know. In this example, this and this is discrete analysis because the money increasing like stairs, so it's step by step. And suppose you have P, it's a time. You deposit and the money increasing like that. Okay, like stairs. However, sometimes we have no information. This is the future value. Suppose you have no information exactly, or the period is too small. For example, in the stock market, the stock market price change in 5 minutes. Therefore, we have another analysis que es continuous. Continuous analysis. This is the time. This is the future value. And the present value is the money. But in this case, continuous. No stairs. No, es continuo. Entonces, the formula is different. Future value is equal present value, exponential RT. This is for continuous. And present value is equal future value, exponential minus RT. Okay, this is analogous, no? This formula and this formula is analogous in the problem of future value. But this is discrete analysis and this is continuous analysis. And this is same thing, present value, but this is discrete analysis and this is continuous. Maybe it's not clear for you, but now when you see the word problem, you understand very well this. Okay, so basically we have four formulas. Let's do in the first problem. Well, actually the first problem is this. Okay, entonces compound interest. If $10,000 es invested en account, o sea, I suppose que present value is 10,000. An account at 3% APR. This is interest rate. So R is interest rate, remember, but in the formula you never plugging in percentage. No. In decimal approximation. So you divide by 100. That you convert percentage to decimal, no? Divided by 100, entonces 0.03. Okay, and you plug it in here. Always in decimal, never in percentage. One more information. Compound quarterly. Oh, entonces compounding is 4. So my bank account each 4 months is a quarterly period increasing my money. How much money will be the future value? And will be account in 5 year time. 5 years. Always the time is expressed in years in that formula. Okay, now plug it in. Okay, so now let me try to erase that part. Okay, guys, this is a moment that everyone help me and using your own calculator. Future value is equal present value parenthesis 1 plus R divided by N T. This is exponent NT. So the future value, que is the thing I want to find, is 10,000 parenthesis 1 plus 0.03, que is R, divided by 4, and raised to the multiplication NT. N is 4, T is 5, and 4 times 5 is 20. The exponent is 20. And please, you put in a calculator. Come on. I put in my calculator, you put in your own calculator. Okay, it's 10,000. Come on. This is important. The skill of the putting your calculator is important for the test. The 10,000. Don't forget this 4, 1, 2, 3, 4, 0. Multiplication, parenthesis, open the parenthesis, 1 plus 0.03 divided by 4 plus the parenthesis power 20. Boom. Look at the answer. What answer you get? Come on. Nobody working with the calculator. Say again. 11.
I got 10,000.
No. Hello. You deposit 10,000.
11,000.
Eh? What do you say?
I got 11,000.
Pero 11,000 alone. No cent, no 100, no something. 11,000. I get in my calculator $611.84. You get that or no? Eh?
Now I did. I messed up the parentheses.
This is the skill of the calculator for solving that kind of problem. Okay? Everyone get this answer? This is my first problem. It's easy, extremely easy. Everyone follow me? You get the same answer? Honestly. So you need one specification. I put in my online calculator and I compute it in front of you. You need to show you in my online calculator or no?
Yes, can you show it?
I try. Let me try. There you go. Let me open here. Okay, good. Let me try to share the calculator. Do you see my calculator or not yet? Do you see?
Yes.
Yes. Super. Okay, entonces es 10,000. Multiplication. Open the parentheses. 1 plus 0.03 divided by 4. Outside the parentheses you put power. Again, the majority of the calculator, the power symbol is the key que have a sign similar to the roof of the house, you know? And this calculator, no, it's different. It's 20 here, 20. And this is the answer. 11,611, and you round off to the near 100, not 100, because it's a money, it's a currency. Therefore, you want to see only the cent. Okay, no decimal of the cent. Do you see that? Good.
Yes.
Okay. Let's move on to the second problem. So you have no questions. Okay. This is the second problem. The second problem talking about John wants to buy a 30,000 car.
Professor, we still see decimals.
Okay, sorry. I want to share whiteboard. Now you see?
Yes.
Okay. Okay, John wants to buy a 30,000 car. He has saving 27,000. Find the number of years it will take from his 27,000 to grow to 30,000 at 4% APR compounding quarter. So he John deposit the money. Deposit your his original money, okay, by the way, is 27,000, and one bank account expecting get the money increasing to 30,000, and now he is ready to buy the car. Okay, so I need help. What information is given? What is the present value? What is P? Present value. What is the present value?
27,000.
27,000. What is the future value? It's given or no? Future value is given or no? No?
30,000.
Exactly. Okay, one more information is given. It's giving the interest rate. Huh? What is the interest rate in this account?
$0.04.
Very well. 0.04. Convert percentage to decimal. And the compounding is quarterly, therefore it's 4 again. No? And so what is my unknown? What is in the formula? What is the thing I want to find? Time. How many years? Time is the thing I don't know. Okay, I come back to my formula. My formula says que present value, future value, future value is equal present value 1 plus R over M NT. This is my formula. Okay, this is 30,000. This is 27,000. Parenthesis 1 plus 0.04 divided by 4 raised to the NT. N is 4 and T I don't know. Yeah, I need to find that. Well, in this case, we have the exponential equation, no? Because my unknown is located in the exponent part, right? Okay, let's do a little bit algebra to isolate that. You divide 30,000 divided by 27,000. Okay, and this is super easy because at least 3 zeros cancel. And you divide by 3 is 10 over 9. No? Because the 30 divided by 3 is 10, 27 divided by 3 is 9. Okay, and the other side, we have 0.04 divided by 4 is 0.01 plus 1 is 1.01 raised to the 40. Good. Let me copy my equation. 10 over 9 is equal, parenthesis, 1.01 exponent 40. This is a classical exponential equation that you solving applying a logarithm on both sides. Well, what kind of standard? What kind of standard? Either way that you want. I'm using in my paper LM. There are no special reason. You apply LM on both sides. In that moment, I apply the property number 7, que es fantastic. Allow me the exponent go to the front as a factor. How am I going to remember T? You divide both sides by 4 ln 1.01. So my answer is ln 10 over 9 divided by 4 times ln 1.01 equal T. But I need to know how many years. No, this is a horrible formula. So I put in the calculator. No, come on, let's do it. Help me with the calculator. If you need assistance, you let me know. I put in my online calculator. Natural logarithm of, be careful with the parentheses. Come on, this is for today. Try. How many years? 5 years, 10 years, 15 years, 3 years, 2 years. John need to wait to buy the car. Nobody get that? Nobody have answer?
It's like 2.5 years.
Exactly. 2.6.
2.62.
2.6. Very well, mister. 2.6. Bueno, okay. Years. Let's see years. This is 2 and a little bit, 2.5, a little bit more than half. Actually, 2 point something. Almost 3 years. Young need to wait. Any question? Some student need can explain in the online calculator how you compare that? Or no? Come on, this is the moment to say yes or no. Everyone get the answer? Come on,
Yes.
answer. Yes, okay. So I can erase, I go to the second problem, no?
Yes.
Okay, yes. To the second problem. Okay. To the second, no, to the third problem. Okay. Okay. This is similar. No, it's not similar, it's different. It's a find the future value that result from investing a present value. Okay, present value is given. So capital P is given. Present value is 2,000. At APR is interest rate 0.08. Always remember divide by 100, present decimal. Compounding continuously. Continuous is a continuous analysis. Therefore, the formula is different for 1 year and 10 years. Okay, 1 year and 10 years. So you have to answer, no? 1 years and 10 years. Pero bueno, let's do it one by one, no? And what is the formula? The formula is future value. Okay, is my unknown, no? Future value. I need to find future value. Is equal to P exponential RT. R is the interest rate and T is the time. Okay, so A for 10 years, for 1 year, sorry, is 2,000. Exponential, E, pero this kind of exponentials are using the base E, 0.08 times 1. And future value for 10 years is same amount, E, 0.08 times 10. Boom, 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 boom. Okay, let me see. Come on, everyone, compute that. 2,000 multiplication exponential. Exponential is here in my calculator. So you need to investigate in your own calculator what is the E. So again, by the way, it's the same key of the natural logarithm, is LM, where you press shift, no? I suppose. 0.08 times 1 and 0.08 times 10. Boom. Okay, got it. You get answer or no? You don't know how you using the exponential?
Got 2,166.
Is 2,166. And how many cents?
57 cents.
57 cents. Very well. And what about the second? 10 years.
The second one's 4,451. And 8 cents.
Exactly. Very well. Some students need help to compute this in the calculator. Come on, I can use my online. I know that my online calculator is not equal to your calculator. you need to discover how you find the exponential e to the x in your own calculator, no? Okay, no? We continue to the next problem. May I erase the board?
Yes.
Okay.
Yes.
Okay, next problem. Next problem is about here, over there. It's about investment. But investment using bond. A bond, you know, you can buy bond. And the bond have a direction of the bond. When the direction is called a maturity ending, and you receive more money. This is one possibility. Not necessarily you invest in bank account. No, you are using another financial tools to increase in your money. No, okay. So a bond can be redeeming in 10 years. Okay, this is the maturity time. How much should be willing to pay it now if you want to return off? Then we have two kinds of problems. It's compounding monthly, okay, discrete analysis, and 6% compounding continuously, que es continuous analysis, ¿no? Entonces now I need one extra information que is not given in the problem. I need to fix it that. Que you expect to get when the bond is redeemed in 10 years, you expect 1,000 dollars. So the issue is 1,000, 1 million is not important. This is the irrelevant quantity. The problem is that somehow it's giving the future value. This is the future value. So the future value is 1,000. Entonces now the question is how much should be willing to pay now. Entonces now we indicate present value, no? Present value is the thing I don't know. Entonces we have two conditions que es interest rate es 0.07, pero monthly, n equal 4, this is discrete analysis. And the formula for the discrete analysis is future value is equal present value 1 plus, oh no, much better, let me isolate the present value, is the thing I want to find. So present value is future value divided by, it's the same formula, no? But you isolate present value. 1 plus R over M into. And we have another problem here, let me write here, okay, in which the interest rate is 0.06. This is continuous, so no M, and have no sense. N is like infinity period. Now is analysis discrete, no is continuous analysis. In this analysis, the formula is different. It's present value is equal to future value e to the minus RT. Okay, let's do it. Entonces, present value is equal 1,000 divided by 1 plus R, que R is 0.07 divided by 12 because it's monthly. Pero sorry, es monthly, ¿no? ¿Es monthly o es quarterly?
Monthly.
Monthly. So no, I make a mistake here. It's 12. Raised to the well. 10 years. In 10 years, N is T is given, sorry, I forgot to say that, 10 years. Here exactly the same, 10 years, T 10 years. Ok, entonces es multiplication, N and T together, no? N times T, que es 120. This is the exponent. Wow. And makes sense because it's 10 years and any month the money increasing. And how many periods we have? 120 period. Put in the calculator this. And likewise, you put it here. 1000 exponential minus 0.06 times 10. Come on, working. Calculator. Discrete analysis, continuous analysis.
For the discrete, I got 497.60.
Excellent. 497 and 67. This is the price now of the famous bond. A bond you purchase it for this price. And after 5 years, you get 1,000. This is the idea. And what about the second?
The second, I got 548 and 81 cents.
Very well. Super good. You are good doing this in your own calculator. Bueno, entonces si you need to make decision what is the best option, it's obvious that the best option is this, no? Because this price is cheaper than this. But this is the best option. Entonces now in the test, in the review package also, you have two possibilities, you have two options, and you compare both and make a decision what is the best, no? Depende, no? In this case, when you compare present value, the best option is the option that have the lower price. However, when it's the future, it's opposite. Okay, suppose you are doing investment. What's the best option? The best option is the option can produce the higher return, no? The higher future value. Okay. Okay, this is the idea basically about finance. Now let's do now a problem that somehow involve biology, chemistry, physics, and you apply exponential and logarithmic application, no functions. Okay. Okay, there you go. This is about biology. Wow. A certain insect population growth, according to the law of uninhibited growth, initial amount of insect was 500. Grow up 611 in 10 years. 10 days, sorry. How many insects have an amount? Okay, I understand. Okay, let me try to understand this. This is the exponential growth. No, the exponential growth, the formula is population to any time is equal to P null. P null means initial population. Initial population multiplication time e to the kt. And k is similar to the r in finance. It's like a rate of change in which increasing. Okay, somehow it's given, but a little bit higher. Okay, so let me try to understand the idea. The idea is this graph helped me to understand. At least for me, it's visual. This is time. Okay, by the way, it's in days. The problem talking about days. And this is the amount of inset population to any time. At the beginning, we have 500 inset. This is P null. This P null is 500. E to the KT. Okay. So now, and the problem say que in 10 days, this is 20, and this is 30, que es a month. We have 611. Suppose 611 inset. Okay, entonces my exponential walking like that. Exponential growth. And I need to find the population in 30 days, que es equivalent to 1 month. This is the thing I would try to find. This is my goal. This is my goal. Okay, we have P null, que es condition 0. Condition 0 is P null. Condition 0 give me the information. Okay, this coefficient is 500. Condition 1 is the condition que es given extra, que allow me compute the K value. So it's not clear what the K. And the finance is clear, because I deposit the money and the interest in the bank, and the bank, the APR is 5% or 2%. So this is given explicitly clear. But in biology, no. Or in another science, no. It's not explicit what is the rate of change of the exponential. Entonces you find. Okay. Entonces, condition 1, help me to find K. Somehow. And condition 2, que es the last one, is the condition que I need to compute the final answer, que es the final or the future, population. Okay, let's do it. Let's move on to the condition 1. Condition 1 here to find K. Well, in the condition 1, I have whole information. I have the P and 10 is 611 is equal 500 exponential K times T, que T is 10. The only unknown that we have in this equation is K. Okay, so I take advantage to find the K value, no? You divide by both sides by 500. Why not? 611 over 500 equal e to the 10K. I want to put the number, the coefficient in the front. For me, it's more elegant. Now you apply logarithm on both sides. It's a classical exponential equation that you apply logarithm on both sides. What kind of logarithm is the most convenient to apply? Well, natural. Because I know que natural, que es ln, is associated with the base e. Right? So you apply natural here. And you apply natural here. Es obvio que this logarithmic and this exponential, que is the same base, undoes each other because they are inverse function, and the answer is 10K. This is similar to the property number 3 that we studied in the last class. The property number, let me refresh your memory. Logarithm of the any base of the exponential is equal to x. The interpretation is like a logarithm and exponential cancel out. Okay, now finally, divided by 10 both sides. Divided by 10 both sides. We have natural logarithm of 611 over 500 divided by 10 is K. Very important, the thing I want to explain now. This is not the final answer. This is a partial answer. As you see in the display of the calculator and you copy in the piece of paper, you lost accuracy in your information because you are trunking the decimal. So my recommendation is you copy in the piece of paper, okay. However, you store in any memory of the calculator, because any calculator, any modern calculator have one key to store a numerical value, no? Que it's not the final answer, the partial answer, no? Suppose in my calculator, okay, I have two calculators here on the desk. One sophisticated and one cheaper, right? And the cheaper, I put natural logarithm of 611 divided by 500. Everything inside the parenthesis, close the parenthesis, division by 10. I press the enter. I get approximately, because I trunk it, 0.002. Yes or no? However, in this moment, I want to using this case for the next step. Now I put it in memory. How you put it in memory? You press the key store, still. You press still and the cheaper calculator, and you select the memory. I select, we have different letter A, B, C. I select A, default is A, and press enter. Bang. Thus I know that A memory is that number. Okay, A memory is that number, 0.02. Okay, so you don't know exactly the memory of your own calculator. Okay, no problem. No problem because, bueno, another possibility is use the answer key. Okay. Let's move on to the next step. The next step is find the population at 30 days, que es a month. I need to find population at 30 days. Is 500 again, que es P0, exponential K, pero in this moment I have K in my hand, que es that value. Multiplication by 30. Okay, entonces I have in my calculator 500, again, time, exponential, okay, second exponential, and I put K, but K in my calculator that I have in my hand right now is A, no K, it's A. Memory bar, select A time 30 days. Close the parenthesis, press enter, bang, ya get the answer. The answer is 912. You trunk it is really stupid to consider a decimal of the inset, no? Remember, we are talking about animal, entonces 912.3, entonces you trunk it like that. Inset, that's the answer. You get the same answer like me or no? Yes or no? Yes. It's easy. Do you understand the idea or no? Complicated, easy. Come on. I need opinions. Clear, it's clear. Okay. What is the reason I hear you too far? Okay. No problema? Do you understand that word problem? Okay, this is classical exponential growth. You see exponential is going up, increasing function. No? Next problem is exponential decay. Let me try to explain exponential decay. Exponential decay. PowerPoint. Application logarithmic. This one. Okay, this is about, let me explain, it's a physics problem. This is about the, the test case using for archaeology to determine the age of the different objects that they found under the ground. No? So I need to, so the test is called carbon-14. Carbon-14 is an isotope, a radioactive isotope. Entonces they testing the amount of carbon-14 que contain the piece of the something que discovered and compute the number of years of the age of this. So in this problem, talking about traces of burned wood, wow, along with ancient stone tools were found to certain approximately 1.67% of the original amount of carbon-14. This is the amount of carbon-14 que the detector, this instrument detecting in this wood. If the half-life, what is that? Well, half-life is, let me explain half-life. Any isotope, radioactive isotope, have a half-life. This is the time, and this is the amount of substance. At the beginning, you suppose in relative unit it will have 100% of the carbon-14. However, this is decreasing with the time. Because remember, the isotope is the atom is unstable and decompose. This is the isotope, radioactive isotope, now decreasing the amount of carbon-14. So during the time, decreasing. And half-life is when you have 50. 50 has half. So each element, the physics study, each element, carbon-14, the half-life is 5,600 years. So this is 5,600 years. Wow, a long time. However, our sample have only 1.67%. Wow, 1.67%. I need to find the time for this. This is my goal. It is my unknown time, H. This piece of wood. And again, we have condition 0, it's initial always. We have condition 1. Condition 1 allow me to find the K because the formula is the same. The formula is population, but no population, it's not population, it's population is in the insect animal. This amount of substance at any time is equal A null, que es initial, que yo I suppose en relative unit es 100%. E to the KT. To the KT. Entonces, bueno, profesor, es the same formula. Yeah, it's the same formula. What is the only difference? The only difference is that this is decay problem. If it's decay problem, now K is negative. I don't put the negative here. No, because when I manipulate in the problem, you discover that K is negative. And now it's a classical example que es decay. This exponential is decreasing. Okay? So look at the formula for the growth is exactly the same. P null e to the KT. This is growth. But and the difference is that K is negative and here K is positive. That's it. Okay, so now I try to do. At the beginning, I know that amount of substance to any time is 100%. In this case, you can use in percentage. You can. Oh, if you want, divided by 100, this is 1. But it's the same. That doesn't change the problem. Exponential KT. Remember, always condition 1 is using to find the K. K value. The K is the rate of change of the exponential. Well, let's do it. So it's, and that moment I know, suppose condition 1 moment que is 56 years, we have 50%. 100 exponential K time, the time associated with that time is 5,600 years. The only unknown in that problem is K. Divided by 100 outside, Bueno, es obvio que 50 divided by 100 1/2 or 0.5 either way is equal to 5600 multiplication by k. One more time, you apply logarithm of both sides. Of course, natural, because the base is e. And in principle, you can apply either. However, no, it's very more convenient apply natural because when they have the same base, undoshes in each other. No, this is actually 5600k because I know very well that this and this say goodbye. Now the k value is natural logarithm of 1/2 divided by 5600. And immediately I can see, wow, k is negative. Why is negative? Because in the process, you compute logarithm of 1/2. And I know very well que el logaritmo of the number less than 1 is negative. Entonces the answer is, wow, it's a weird number. I put in the calculator, it's negative 0.000123778. Another calculator offers the answer in scientific notation. And scientific notation is negative 1.23778 something times 10 to the negative 4. And remember, this is the partial answer, not the final answer, and you store in one memory of your calculator. Okay, because I'm using the second step. Okay, and the second step of the problem is the condition 2. And the condition 2, I know que the amount of carbon 14 is 1.67. Entonces, the formula is the same. Amount of substance to any time is equal A null e to the kt. But the problem is that now I know k, que is that number. Okay, by the way, I put inside my calculator, no? Okay, so now this is 1.67. This is 100 again. Multiplication e to the k, que is that number I don't want to repeat. I call k multiplication by t. And t I don't know. So you one more time, you apply logarithm of both sides. Well, first of all, divided by 100. Apply logarithm of both sides. Logarithm of 1.67 divided by 100 is equal k, t. Now t alone is logarithm of 1.67 divided by 100 divided by k, and I know that k is that number. And give me the answer. Put in the calculator one more time. I have 33,062 years. Okay, this is the age of this piece of wood. Of course, this is approximation, no? But it's one idea that give me us the information how antique is this piece. At least classification, not exactly in the years, you know, in the age, in the period of time of the human being, no? Okay. I promise that in the review package we are doing more specific word problem. Okay. I suppose que don't worry for the test date because I need to change. Definitely we lost one day, remember, eh? For the spring break. No, spring break is the meeting for the so we lost one day, so I suppose que I need to extend a little bit the date for the test number 3. Okay, let's move on to the last problem. In the last problem, In the last problem, we have a completely different idea. Oh, let me see. PowerPoint. PowerPoint. There you go. Okay. This is completely different problem. It's a basic physics problem. It's about Newton law cooling. What is the idea for the Newton? Okay, suppose you have one object here. Okay, it's very, very hot. Suppose, I don't know, 400 degrees Fahrenheit. And of course, transfer heat to the environment. And the environment maybe is, I don't know, 70 Fahrenheit degree. Okay, and it's obvious, this is temperature. Capital T is temperature, little t is time, and minute and second, a minute, in this case minute, 5 minutes, yeah, 5 minutes. Entonces the initial temperature, Ti, is 400. And no, in this problem, I don't read the problem, and I explain theoretical part. And the final temperature is 70 Fahrenheit degree, because I know que stop the transfer of heat when the temperature is the same, no? So you have, for example, 71 and 70, and the environment is still continue the heat transfer, but not too big. This is low because the difference of temperature is small, and it's just 77, stop, no heat more transfer. Then the final temperature is 70. And the process is non-linear, it's exponential, because in the same measure que this temperature decreasing, less heat transfer. So it never finish, you know? It's exponential. And the formula for this temperature to any time, que es the famous Newton law cooling, is temperature to any time is equal temperature final plus temperature initial minus temperature final e to the kT. And famous K, K depending, you know, the environment, si es air, si es something, o sea, depending the physical condition. It's not important to say now. Okay, so let's come back to our problem. See, you understand the formula a little bit. Let me erase that part. Okay, this is the formula for the Newton, no? Newton cooling. Okay, in our specific example, we have object to heat it to 100 degrees. So no, this is not 400. No, it's 100. In our example, it's 100. The initial. And is allowed to cool in the room whose air temperature is 30. Okay, 30. This is Celsius, no Fahrenheit. This is 100 Celsius degree. This is 30 Celsius degree. If the temperature of the object is 80, so in one intermediate value, 80, I suppose that this is the condition 1. Always we need the condition 1. This is the condition 0, que es the initial. This is condition 1, in which I have whole information. The temperature is 80 and 5 minutes. And condition 2, when will its temperature 50? So we have another condition here I call 50 Celsius degree. And here is condition 2 in which you don't know at what time. This is my goal. At what time this? Do you follow me? Do you understand the basic idea? Now let's move on to the mathematical part. But do you understand the idea? You have condition 0, 0 time, 100 degree. In 5 minutes, the temperature decreasing to 80, cooling process. I need to investigate what's going on at 50 Celsius degree and what time, of course, this. Okay, so this is my formula. My formula is temperature to any time is equal 100, no, 30, just the final temperature, 30, plus 100 minus 30, e to the kt. And my specific formula is 30 plus 70, e to the kt. Okay, more clear, huh? Okay. Now I move on to the condition 1. Condition 1 is temperature is 80. Condition 1, 80. Okay, this happened at 5 minutes. So this is temperature at 5 minutes. Is 30 plus 70 e to the k. I have no idea who is k. Multiplication by time get 5. So my only unknown in this problem now is k. But it's easy. Let's do it. Is 80 minus 30. Okay, 50, no? 50, well, okay, 70 e to the 5k. This is 50 is equal to 70 e to the 5k. Divided by 70 both sides. Okay, actually 5 over 7 because I cancel out that 0 equal e to the 5k. Apply natural logarithm both sides. One more time happen. Okay, this is a natural and the base cancel out f5k, therefore k alone is natural logarithm of 5 over 7 divided by 5. And this is k. And this is partial answer. So now I take advantage of my memory and the calculator. When I put in the calculator, I get this answer, negative 0.0066729. But I don't copy this. Well, I copy of course, but I don't work with this number you have in the piece of paper. No. I press memory, store in memory. I call any name, A, B, C, depending your calculator have different name to call memory. Okay, now I go back to the second part. The second part is temperature 50. So condition 2 is 50. The formula is the same, 30 plus 70. Exponential. K I have in my hand is that value. Okay, by the way, is negative. And si es negative K indicate us que this exponential is decay. It's going down. And make sense because it's cooling. The temperature is decreasing. Multiplication by T, I have no idea who is T. I solve for T. This exponential equation. This is 50 minus 30 equals 70 e to the kt. This is 20. Divided by 7. 70. Cancel out this 0 is 2 over 7 equal e to the kt. One more time, I apply logarithm both sides. Logarithm of 2 over 7 is equal logarithm of e to the kt, que is equal kt, no? It's exactly the same. Now, but I know what is k. Entonces, el logaritmo 2/7 divided by k. Now who is k? This is k. I put in the memory, I put out division, and the answer is 18.61 minutes. Is the thing I try to find. The time, the temperature of this object decreasing from 100 Celsius degree to 50 degree. A little bit confusing or a little bit clear? Confusing or clear? Question, are you sleeping? Come on, guy. Are you okay?
Yes, okay.
Yes,
Got it, right? Okay, entonces I propose you clear. Okay, super. We'll say clear. I propose start review. We have enough few time, pero bueno, okay. Start. Review. Entonces we continue next time. I don't know if we finish. If we don't finish, we continue next time. Entonces, after when you finish the review at the moment, I change a little bit the due date for the test on paper and the test online. Don't worry, be happy. You only pay attention and try to understand. Let me try to find the review package. I suppose que here. Test 2. Test 3, no? Sorry.
Professor, test 2 through email.
It's test 3, no? That we were working in the chapter 3, no?
Yeah. I think you sent us test 2 instead of test 3.
Ah. Well, sorry. I will send again. And don't worry, in the video I send the link for the YouTube. I send the thank you for reminding me that I'm a little bit crazy. But now it's test 3. Do you see now? Do you see whiteboard or no?
Yes.
Okay. It's test 3. I resent again this. Okay, entonces now where's the job? We're doing that part. Well, in that part is one-to-one function is given, okay. Write the inverse, okay, it's easy. Number 1, inverse function. Number 1, f of x is equal 9 minus x divided by 5. Now I know that y is equal 9 minus x divided by 5, and the original. Now, how you find the inverse? Interchange x and y. This is the key idea. X is equal 9 minus y over 5, and solve for y. Cross multiply, 5x is equal 9 minus y. I move the y to the left. I move the other to the right, 9 minus 5x. Boom, and this is the inverse. Que corresponde with the option D. Super good.
Yes.
Mm. Okay, not bad. That part is easy. Let me know when I can erase. I can erase? I can erase?
Yes.
Okay, moving on to the second. Second is f of x is cubic root, wow, x minus a. Y alone is cubic root x minus a. Now interchange x and y. X is equal cubic root y minus a. Actually, in this moment you have inverse. But the inverse is implicit. I need explicit. To express in explicit, you solve for y. You cube both sides because I need to somehow eliminate the cubic root. I know very well cubic root and cubic power undoes each other. Now y alone is x cubed plus 8. It's a new y, and this new y represents the inverse function. Okay, entonces x cubed plus 8, like a b. Any question? Any question?
No.
Okay. I suppose in the test you have only one question of this, no? In the review we practice 4. Suppose number 3 is f of x is equal 5 x cubed minus 7. F of x, immediately I replace for y. Yeah, interchange x and y. Entonces x alone is equal 5 y cubed minus 7. Solve for y. X plus 7 equal 5 y cubed. Divided by 5. X plus 7 over 5 is equal y cubed. Apply cubic root both sides because I want y alone. And y alone is cubic root x plus 7 divided by 5, like option B again. Wow, easy. How do you feel? How do you feel? You feel okay? Answer me.
Good.
Good. Okay. Number 4. Number 4 say f of x is equal x plus 5 divided by x minus 1. To find the inverse, you replace f of x for y. Now you interchange x and y. X is equal y plus 5 divided by y minus 1. And now cross multiply. You multiply x times y minus 1 equal y plus 5 multiplication by 1, because you suppose k1 is the invisible denominator here. Now distributive. xy minus x equal y plus 5. My goal is y. So I try to xy stay here, minus y, I move this y to the left, and to the right we have x plus 5. Factorization y, greater common factor is y, x minus 1 equal x plus 5, divided both sides by x minus 1. The new y, que es the inverse function, is x plus 5 divided by x minus 1. X plus 5, x minus 1. I suppose que es 1. I don't know why they put 1 coefficient. You know, 1 coefficient is invisible. So this is equivalent to say 5 plus x. See, 5 plus x and x plus 5 is the same. X minus 1. That's the option. Any question? So basically, step number 1, replace f of x for y. So no function notation anymore. Only y. Interchange x and y. When you are doing this action, this action, yeah, already you have the inverse function. The only problem is that your inverse function is not an explicit form. Well, entonces to express an explicit, we need to solve for y, and that's it. You apply the algebra that you know to solve for y. Cool. Perfect. Okay,
Yes.
let's move on to okay, this is the collection of the exponential. Okay, graph the function and write domain and range in interval notation. Okay, entonces I saw clear f of x equal 7x. The base is 7. And 7 is a number greater than 1. Therefore, it's grow exponential. Entonces es obvio que this is wrong. And this is wrong. Right? Because exponential is going up, no down. From left to right. Well, just I need to discover what is this. But I know, okay. To do the graph of the exponential super fast is, look, you have the famous point is 0,1. And you have 1 and -1. In 1 we have 7. That point is the point 1,7. And the -1 is here, too small, que es -1,1/7. Okay, this is my graph. And don't forget also, okay, we have horizontal asymptote here, y equals 0. But okay. So now I need to discover is 1,7. This is 1, 2, 3, 4, 5, 6, 7. This is the famous point 1,7. Let me check it out. This one is 1, 2, 3, 4, 5, 6. No good. This is not good. And domain is obvious in any exponential equation is all real number. Function, sorry. It's all real number, and the range is the positive and not 0 because it's asymptotically. Clear? Wow, easy. Clear?
Yes.
Okay, one more. This is page 3. Huh? Page 3. Okay. One. Page 4. Let me see. Page 4. No? Page 4. I'm supposed to get this. Okay, there you go. This is f of x equal 2/7 raised to the. Again, we have exponential. But what kind? Exponential growth or exponential decay? The base is 2/7. And 2/7 is less than 1. Entonces decay. Then my exponential is going down. Entonces this is no good. And this is no good. We focus in this and this. To do the graph of this, we have the famous point 0,1 and 1 and -1. And 1 we have 2/7. Okay, by the way, 2/7 in decimal is 2/7. I put it in my calculator. It's 0.28. It's super small. This point is the point 1, 0.28. And the reciprocal is 7/2 is 3.5. So 1, 2, 3, 4. Actually here. This point is the point -1, 3.5. Where come from 3.5? 7 divided by 2, no? 3.5. And this is my exponential. Of course, asymptotically to this. So let's check it. 3.0. Okay, 3.5. It's this. Look, -1 is here. 1, 2, 3, and 4. That point. And this is 1, 2, 3, 3.5. It's okay. Oh, it looks like similar. The graph is similar. However, the mistake is in the domain and range. This is wrong. Domain always for any exponential is all real number from negative infinity to positive infinity, and range is from 0 to infinity. Entonces es obvio que the option C is correct. And the option A no. It's the same shape of the curve, but no good domain and range. Any question? Any question? Okay, let's do one more and that's it. That's it. Let me see. See, next one is too complicated or no? Ah, no. No, it's also graphic operation. Okay, in this case, using the graph, this is a transformation. This is a transformation. So my function is 2 to the x plus 1 minus 4. Now the base is 2. Therefore, we expect exponential growth. Everything is exponential growth. Exponential go up, 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 up. But negative 4 represents the asymptote. So the horizontal, no? Asymptote. Add negative 4. Let me see. Negative 4 is okay here. Negative 4. No, no, no. This is no. This is 1. No, no. This is 4. No. This is negative 1. No. It's so big as this. Now the glue, and this part is not super important because this transformation, the only thing they are doing is horizontal shift 1 unit to the left. Okay, okay. I understand. Suppose que yo valoro en 0. The function valor en 0. To understand this is 2, 0 plus 1, minus 4. Entonces, 0 plus 1 is 1, is 2, minus 4 is minus 2. And the famous point is 0, minus 2. Let me check and see it's okay or not. Oh, yes, it's okay. Look at that. This is the point, 0, minus 2. No, the classical 0,1, que is the universal point, but without transformation. In transformation, no, we change something. Okay, guys, so we continue next time with the review. I don't know if we finish or not. If we finish, we are ready to take the test. If we don't finish, well, okay, we continue. Okay. I fixed my mistake. I will send the. Okay, I will send the review. Number 3, no number 2. Have a nice day.
Bye, Professor.
Bye, bye.
Bye, Professor.